Example, we've got two functions drawn on the Cartesian plane, f of x and g of x. We don't actually have any information about the functions. It's possible that we could work out what they are, but we don't need to. What we're being asked to do is write g of x in terms of f of x. And remember, when it's written g of x in terms of f of x, that means g of x is going to be the subject of the equation, and f of x is going to be included somewhere in the equation itself. So the first thing we need to do is work out how g of x has moved from f of x's original position. So if we start down here at 5, 0, we can see that the corresponding position on the g of x is in fact 3, 3. All right, we can see that for our horizontal translation, we've gone 2 units to the left. That tells us that we're talking about g of x being f of x plus 2. It's moved to the left, so it's plus 2. Then we can see that our critical point has moved 3 units upwards vertically, so it has been translated through plus 3. So g of x is actually f of x plus 2 plus 3. The x plus 2 translates at 2 units horizontally to the left, and the plus 3 translates at 3 units up. So the trick with these is just finding a corresponding critical point and moving it. I equally could have used the little maximum here, but I don't have any axis or grid intercept, so I don't know the actual coordinates of that. So pick one that's got nice grid intercepts. On the second one, we're just given the function f of x, and we're told to translate it 2 units vertically downwards and 3 units horizontally to the left. So we can do that piece by piece. So we're talking about g of x, and it's f of x, except we do the horizontal one first. It's translated 3 units horizontally to the left. So that tells us it's going to be f of x plus 3. And the translated 2 units downward tells us it's going to be f of x minus 2. And we've got to put these two things together. It's 3 units horizontally to the left, f of x plus 3, and then 2 units downwards, minus 2. Now, does it matter if we do the 2 units downward first and then the 3 units to the left? No, it doesn't, as long as this is our horizontal translation and the constant at the end is the vertical translation. Now, when it says find the equation of the resulting graph, g of x, what's implied, and probably on a test what will be spelt out very clearly for you, is that it wants it expressed in simplest form. So now that we've worked out that it is f of x plus 3 minus 2, we need to work out what that actually is. So if f of x is 2x squared minus 3x, then f of x plus 3 is going to be 2x plus 3 squared minus 3 times x plus 3, and then we've got this minus 2 on the end, so we just write that down. We can do perfect squares expansion on the first one, x squared plus 6x plus 9 minus 3x minus 9 minus 2. So distribute the 2 into the bracket. Minus 9 minus 2 is minus 11. Collect like terms, 2x squared, 12x minus 3x is 9x, plus 18 minus 11 is plus 7. In the situation where you've got a calculator, a really easy way to check whether you've actually done this translation correctly is to plot both graphs and see what the translation looks like graphically. I've done that here. The blue one is 2x squared minus 3x, and the red one is 2x squared plus 9x plus 7. We've got these inconveniently located minimum points, but what I've got is the coordinates of the minimum. So we can check. We've got 3/4 minus -2 1/4, 2.25, the way f of x has drawn it. If you put that into your calculator, 3/4 take 2 and take -2 1/4 is actually 3. So yes, this is 3 units to the left. And then minus 9/8 minus -25 on 8, is that actually 2? Well, that's minus 9 on 8 plus 25 on 8. Minus 9 plus 25 is 16 on 8, which is 2. So yes, this distance here is 2 as well. So this is 3 and this is 2. And that is the translation that we were going for. So you can check it via a graph. In the next video, I'll just have a quick chat about how to do the example in the textbook.